Okay, this is the next question. We've been given the following table and the figure. We are asked to fill this table up. So let me draw the table first. Okay, that's fine. So this is figure number of dots, and area of the outer circle, that's the largest circle, and area of the shaded region, and this is the total length of circumference of all circles. Now, as long as we have the data, we can get all these values. So figure 1, 2, 3, 4, 5, and then there are a list of figures which are not given. Then we have to give the nth value. So number of dots is given as 5, 9, 13, 17. We need to get the number of dots for number 5. So let me show you that. This number of dots is given by a plus n minus 1 into d. We can use this formula. So the first value is given here as 5. We have to get the number of dots for figure 5. Now the common difference between 5 and 9 is 4, and between 9 and 13, right? 9 and 13 it is 4. And between 13 and 17 it is 4. See, the common difference is always 4. Do you see that? Okay, so we are going to use that common difference. So this is equal to 5 positive, 5 negative 1, 4, multiplied with the 4, 5 positive 4 was a 16, which is nothing but 21. So 21 is your solution here. Now we will have to get for any n. So for that, what we have to do here is for any n, it's 5 positive n minus 1 into d is 4, which is 5 positive 4 and negative 4. You add these two together, you get 1 positive 4n or 4 and positive 1. So that is the value here, 4 and positive 1. You see how simple it is? So now we have been given pi, and this is 4 pi. This is 9 pi, this is 16 pi, this is 25 pi, and we have to get the area of the circles, right? Now if you were to observe this also has a pattern: 1, 4, 9, 16 and 25. Okay, now go back to the figure. When you have 5 you have 25, 4 you have 16, 3 you have 9, 2 you have 4, 1 you have 1. So what do you sense here? What has to be the value here, area? If you have n here, what is this going to be? N squared times pi. Okay, that's it. Just study the pattern versus the figure number. Now having got that, let's move on. This is the area of the shaded region. You have a pi here, you have 3 pi, you have 5 pi, you have 7 pi, and you have to get this value of the area. What should be the area? Now between 1 and 3 you have that common difference 2, between 3 and 5 common difference 2, between 5 and 7 common difference 2. So what I'm going to do, I'm going to use the same thing. So the first value here is a is 1, and n minus 1 times d, common difference is 2. Now we need to get for 5, right? So 1 positive 5 negative 1 times 2, 1 positive 5 negative 1 is 4 times 2, which is 1 positive 4 times 2 is 8, which is equal to 9. So this is 9, but since we have pi here, you need to place pi there. Okay, fair enough. So now we need to fill up this information. We need to get this value. So what should be the value for nth term? So just go here. For nth term, it's going to be 1 positive n minus 1 times the common difference is 2. This is 1 positive 2n negative 2, which is nothing but 2n minus 1. Okay, I hope you're watching it. So if you had to substitute, the value is going to be 2n minus 1 times pi. Okay, fair enough. That's a completion for this question. So now the total lengths of circumference. So you have 2 pi here, you have 6 pi, you have 12 pi, and then you have 2 pi, 6 pi, 12 pi. This is 20 pi, and you have to get the value here. Okay, so you study the difference here. 2 and 6 difference is 4. 12 and 6, the difference is 6 here, and 12 and 6, the difference is 6 here. So this is 8 here, the difference is this is 20. 12 and 20, this is 8. So how are we going to get this pattern here? Okay, so you see here the difference is 4 here, 6, 8. So it is incrementing in steps of 2. So obviously this is going to be 10. So what should come here so that the difference between this number and this number is 10? Obviously it's going to be 30. And since we have pi consistently being present, we need to place pi there. Okay, so we have got that. Now the question is, how do we get the nth term? For getting the nth term, go to the serial number for the figure. Now when it is 5, we are getting a value of 30 pi. So find out how many times 30 can be divided by 5. Obviously it's going to be 6. Similarly, go and check for 4 and 20. How many times 20 can be divided by 4? 5. How many times 3 can be divided by 4? Or 3 can be divided, or in other words, how many times 12 can be divided by 3? 12 can be divided by 3 4 times. So clearly you see the steps are actually augmenting. When you have 3, you're getting 4. When you have 4, you're getting 5. When you have 5, you're getting the value 6. So obviously the nth term should be n into n plus 1 times pi, right? Because 5 times 6 only is providing us the value of 30. 4 times 5 only is giving us the value of 20. 3 times 4 is giving us a value of 12 over here. So obviously this is going to be n times n positive 1 times pi, right? So we move on to the next one. Okay, this is the next question. They are asking us to find the number of, say, let me write that down. Determine the value of n when the number of dots is equal to 541. Now we know the following. We know the number of dots is equal to, go back to the table, we know this value 4n positive 1. So this means 4n positive 1 is equal to 541, which means 4n is equal to 541 minus 1, which means 4n is equal to 540. Therefore n is equal to 540 divided by 4. 4 divides 1 time, 4 divides 2 times, 12, 20 and 5. So n is equal to 125. That is the answer to this question. So this is the next question. Write down in terms of p and pi the area of the largest circle in figure 3p. So this means n is equal to 3p. So therefore required area is going to be 3p raised to the power of 2 multiplied with pi, which is nothing but 9p squared pi. Okay, that's the answer to this question.